GCSE Computer Science, Paper 1, Topic 1.5a, Network Topologies, Protocols and Layers. Recap. In previous lessons we've looked at what a network is, a collection of more than one device connected together, why people might create networks to communicate, to share resources, to centralize the management of the network. We've looked at the difference between LANs and WANs, local area networks over a small geographical area, wide area networks over a large geographical area. We've looked at performance factors that can affect the speed of a network, for instance the type of connection used, the number of simultaneous users. We've looked at the difference between a client server and a peer-to-peer network. We've looked at different types of network hardware, the devices needed to connect a computer to a network. We've looked at what a domain name server is, the difference between hosting, what the cloud is, and the concept of virtual networks. In this session, we're going to look at two key concepts. We're going to look at two different network topologies, star and mesh, and we're going to look at the difference between a wired and a wireless network connection. So, what is a star topology? Well, in a star network topology, there is one central device in overall control of the network. In this diagram, that's represented by this thing called the hub, which all the other computers connect to. In some diagrams, it might be represented by something called a switch, which is very similar to a hub, or it could be represented by the server that we're familiar with from a client-server network. But the key concept here is that we have a central device or hub to which all the computers connect to. And each node is connected to that central server, and all communication travels via that central hub or that central server. So what is a mesh topology? Well, in a mesh topology, there is no central server in overall charge. Each node connects to each other node, and you may get what's called a full mesh, in which case every device in the network connects to every other device in the network, or you might get a partial mesh where a device connects to only some of the other devices in the network. So the advantages and the disadvantages of a star topology. The advantages of a star topology are that it is cheaper, it requires less cabling. If you go back to the diagram of the mesh topology, you can probably see that the mesh topology would indeed need more cabling. In a star topology, it's easier to add new nodes to the network, since you just need to add one extra cable to that hub or to that central server. Failure of one particular node is not critical to the whole network, and you've got centralized control over the overall network through that same server. Disadvantages of a star topology. There's a single point of failure. If that central node, hub or server goes down, you will have lost access to the entire network. And since all communication has to go via that central hub or server, then potentially that can lead to a bottleneck, or it can slow down the network. And also in a star topology, you'll need extra hardware, such as hubs or switches, to make the network work. Advantages and disadvantages of a mesh topology. Let's look at the advantages first. A mesh topology can give you a high data transmission rate. There's no single point of failure, and it distributes the load better across all the available connections, unlike, say, the star topology, where all communication had to go via that central hub or server. And adding additional devices does not require any downtime of the network. You don't need to take a mesh network down while you add new nodes to the network. But disadvantages of a mesh topology. It can be expensive, since you need lots of cabling. Again, look at the diagram for a mesh topology. You'll see that every device has a connection to every other device. This is going to require a lot of cabling, and cabling costs money. And since every device potentially connects to every other device, it can be time consuming when it comes to add new nodes to the network, new devices to the network, since you need to install all that additional cabling. And of course, you may have lots of redundant connections that actually don't get used or don't get used very often in the network. So at this stage, it might make sense to just pause for thought. Can you draw a diagram of both the star and the mesh topology? It might make sense at this stage to pause the video, get a piece of paper and try and draw out a diagram of a star and a mesh topology. And can you discuss or write down the advantages and the disadvantages of each type of network topology? Ensure you understand these concepts before you move on. Let's look at the basic differences between a wireless or a wired connection to a network. A wired connection is generally always going to be the faster and the most stable connection. It's less susceptible to interference, it's less likely to break down just because there's an object in the way, because you have a physical connection to the network. You're literally plugging your device using a cable into the network itself. A wired connection can also be more secure in that you're not broadcasting data through the air, so to speak. You're broadcasting the data down a cable. So a wired connection will give you a more secured connection, making it less likely that people can actually intercept the data that you're transmitting. On the other hand, in a wired network, it's easier to add a new device to that Wi-Fi network. You just connect your device to the Wi-Fi network, if there's a password, enter the password, and off you go. You don't have to find a cable, you don't have to plug that cable in. Issue with a Wi-Fi network, though, is that it may be less secure. If you're broadcasting data through the air, so to speak, then anybody with a Wi-Fi device can actually pick up that data. So it's essential that if you're connecting to a Wi-Fi network, you really need to check that the data is being encrypted, that the data is being turned into gibberish by your device before it's actually broadcast through the Wi-Fi network. Let's look at a few characteristics of a Wi-Fi network. And a Wi-Fi network has two really important settings that you need to consider when either you're setting one up or you're thinking about purchasing one. The first one is the frequency of the Wi-Fi network. There are two main frequencies at the moment, 2.4 GHz and the 5 GHz frequency. And just like our processors and our clock speed, the higher the gigahertz rating, the actual faster the network is at transmitting data. So a 5 GHz network will transmit data faster than a 2.4 GHz network. The only problem with that is that the faster the Wi-Fi network, the more likely it is to suffer from interference. So 5 GHz network will struggle to get through certain walls perhaps in your house. And the further away you get from it, the speed will drop down much more fast than, say, the 2.4 GHz network. And you've also got a potential issue that some older devices won't be able to use the 5 GHz frequency. The other factor you need to consider on a Wi-Fi network is its channel. The channel of the Wi-Fi access point works in such a way that each different Wi-Fi network in a particular area needs to operate on a different channel. If you've got two Wi-Fi networks sat next to each other or in close proximity to each other, and they use the same channel, this is not going to be a stable environment in which to use that Wi-Fi network. So it's really important to make sure that two Wi-Fi networks that are close to each other don't broadcast on the same channel. This slide here just illustrates those two characteristics of a Wi-Fi network. Its frequency in the graph at the top, and then the different channels in the chart down at the bottom. In the graph at the top, you can see that the 2.4 GHz network has a better tolerance to interference, whereas the 5 GHz network is less tolerant to interference. You can see that the 2.4 GHz Wi-Fi network has a larger range compared to the 5 GHz network, but the bandwidth, the speed of the 5 GHz network here is much faster than the 2.4 GHz network. You can see in the channels in the diagram down at the bottom that there is some overlap between these channels. And as is pointed out in this diagram, the best channels to use tend to be channel 1, channel 6, or channel 11, as there's less chance that these channels will actually overlap with other channels. We briefly talked about encryption on one of the previous slides, in particular when we were talking about broadcasting data over an open channel, such as a Wi-Fi network. And encryption is key if you're going to connect to a Wi-Fi network, particularly if it's a public Wi-Fi network in a shop or a cafe. And the first thing to do is make sure that that Wi-Fi network is indeed encrypted before you try and connect to it. And the reason for this is that if we encrypt the data before we send it, then we're in effect turning it into what looks like gibberish, just random data, before we actually send it across the network. And there are two main types of encryption that might be used on a Wi-Fi network. There's WEP, Wired Equivalent Privacy. Now this is not very secure. This is an old Wi-Fi standard. And if a network is simply encrypting the data using WEP, you really do need to think twice before you connect to it. WPA, Wi-Fi Protected Access, is the more modern security offered by Wi-Fi networks. And it will require you to log into the network, the Wi-Fi network, using a password or a key. And this will then ensure that the data that you send, your bank account details for instance, will be secure as they're sent across that Wi-Fi network. An alternative name for a wired connection to a network is what's called an Ethernet connection. So an Ethernet connection is simply a wired connection to a network. It's going to be faster than Wi-Fi, and the connection is going to be more stable because it's less susceptible to interference. And you're not sharing the sort of bandwidth of the Wi-Fi network with potentially more than one device in the household or the building. An Ethernet connection, a wired connection, will also be far more secure than a Wi-Fi connection, as again, you're not broadcasting data through the air, so to speak. So again, now would be a good time to pause for thought and just make sure that you've understood the content that we've looked at on the last couple of slides. Can you explain to yourself, or indeed write down, the difference between a wired and a wireless network connection? Can you talk about some of the advantages of a wired connection compared to a wireless connection, and vice versa? Can you explain the difference between the frequency and the channel of the Wi-Fi network, and why these settings on a Wi-Fi network matter? And can you explain what encryption is, and why it's best to encrypt data before we send it over a Wi-Fi network? If you can't, again, revisit some of the previous slides, go over the content again, and see if eventually it starts to make sense to you. So finally, it's worth again asking yourself the question whether you've understood everything in this particular presentation, and if not, go back and revisit the content. Try writing down some of the key terms and some of the key concepts in your own words. Don't just copy from the slides. Look at the slides, but then write down the key terms, write down the concepts using your own words from memory. Maybe even make some flashcards, where on one side of the flashcard you have the key term or the concept, and then on the other side of the flashcard you have the definition. Not only are these flashcards useful for your own revision, but it also means that you can get somebody to test you with these key concepts that actually knows nothing about computer science, since they'll have the key term and the definition on the card in order to test you. And maybe just get somebody else to ask you some random questions, another colleague, another student who's studying computer science. The more times you quiz yourself, the more times you test yourself, the actual better you will get at remembering these concepts and these key terms.